Welcome to Supercool, the show about real-world climate solutions that cut carbon, boost the bottom line, and improve modern life. Each week on Supercool, we go behind the headlines to pinpoint the stories and data accelerating the low-carbon economy in towns and cities across the U.S. and around the globe. I'm your host, Josh Dorfman. If you're enjoying the show, please give us a follow or subscribe, or leave a review wherever you listen. John O'Donnell has spent more than 2 decades chasing one of the hardest problems in climate: how to decarbonize industry without slowing down. He's led 6 startups, built solar thermal plants across 3 continents, delivered half the world's industrial solar heat. But even with that track record, something was missing. Despite technical success, John struggled to secure the kind of infrastructure financing that leads to massive scale. His technology was seen as risky, too complex, too unfamiliar to slot cleanly into existing industrial systems, and the models investors rely on to fund them. That experience taught John something essential. Climate progress doesn't come from promising technologies. It comes from billion-dollar solutions that fit the modern world. And to get there, a technology has to be profitable, familiar, and financeable, built not just for performance, but for bankability. So when he co-founded Rondo Energy, he built the company around a different kind of strategy. Start with what industry already knows. Use materials the world already trusts, and don't over-engineer. Just innovate where it matters most. Because the opportunity we're talking about today is enormous. Half the fuel we burn globally goes to heat, and a huge share of that, roughly a quarter of all global fossil fuels, is used to power industry: steel, cement, food, chemicals, the factories that make the modern world. And almost none of that heat is powered today by clean energy. Rondo's heat battery takes cheap, excess wind and solar and stores it as high-temperature heat using clay bricks and toaster wire. No rare materials, no behavioral change, no redesign of the factory. Just clean, continuous drop-in heat, already underway in 5 countries across industries from cement to chemicals to whiskey. It's not speculative, it's not experimental, it's the kind of infrastructure technology industry actually needs and global capital can actually fund. The clean energy transition needs infrastructure that's durable, cheap, and trusted. Rondo's just happens to be hot, clean, and made of bricks. Here's my conversation with John. John, welcome to Supercool.
Thank you. It's a pleasure to be with you.
I was listening to a conversation you had recently, and it was almost like a throwaway line at the end. But you said that you don't think there's another company in a venture portfolio that has the potential to scale at the speed and scope of Rondo. The opportunity is so massive. I was thinking about that, of course, for our show. That's really saying essentially 3 things in my mind. 1, huge problem, maybe the biggest climate problem on the planet, or one of them. Huge climate solution, and therefore huge business opportunity. And I found that very interesting just to think about Rondo and heat batteries in that context. And so that's going to be running through my head as we're talking. But maybe you can start by giving us an introduction to you, an introduction to Rondo, and your really fascinating background.
Well, thank you, because everything you just said is exactly right. That is, the reason we are doing this is because I don't see any pathway to make this big an emissions impact at this speed and scale. And that's because half of all the fuel we burn in the world is not for transportation of any kind. It's not for electric power. It's for heat. Half of all of that, a quarter of all the fuel we burn in the world, is for heat, powering our industrial infrastructure around the world, making everything from steel to baby food and everything in between. All those factories, the trillions of investments in all those factories, all those processes, about 3/4 of all the energy that industry buys is heat, not electricity. And look, the renewables industry, the wind and the solar industry have done this magnificent thing of making intermittent electricity cheaper than grid electricity. That was accomplished a few years ago. But it's only the day before yesterday that this other thing has happened, which is that renewables intermittently are now cheaper than simply burning fuel. And we're headed to a world, Jenny Chase of Bloomberg New Energy Finance says, by 2030, everywhere in the industrialized world on a sunny day, electricity is free. That is a world of wealth and abundance. And so the biggest issue is, how do we put that to work in what portions of our economy? And now we're in this decade where energy storage is exploding. It's coming down in cost. It's doing the spectacular thing that it needs to do. Essentially 100% of that industry is focused on storing energy to use it for the electricity grid with some sort of electrochemical process. But this other thing of just replacing energy for fuel, it has to be vastly cheaper. Okay, we checked the box. We've got the cheap electrons. Now we need a really cheap way at giant scale, because it's 7,000 gigawatts to replace the 25% of the world fuel. We need a technology that is cheap enough and go big enough. That's the starting condition for Rondo. My background and my co-founder's background, we spent a decade together, and I spent 5 years before that, building large-scale solar heat systems, mirrors and targets, making steam from sunshine. We wound up delivering more than half of the world's solar industrial heat. Those systems that we built are still apparently like 40% of the world's solar industrial heat, and they're literally a drop in the bucket. Less than 1 gigawatt out of, what did I just mention? Yeah.
7,000, yeah.
7 is the low end number, and I think by the time we get to 2030, it's more like 11. We learned a ton of lessons about building large-scale infrastructure, about financing large-scale infrastructure, working globally. We were working on projects in Chile and the Middle East and the United States and Australia, and the real problems of working with real industrial facilities. I was on a panel with the chief sustainability officer of one of the consumer brands 2 years ago, and he said, my factory teams always hate it when the sustainability team shows up, because they want them to tear the factory apart and replace production processes and increase costs to achieve our sustainability objectives. And that doesn't actually improve the sustainability of that factory, which is competing in a global market for whatever commodity that they're making. Whether you make steel or baby food, you pretty much don't drill your own gas wells. You buy energy as a service. You want to buy renewable energy as a service. That means whatever the technology is, it has to be suitable for infrastructure finance. In order for that to be the case, it must be proven that you can build it at a cost on a schedule and that it will last for decades. That's hard for many new technologies. And when Pete and I started Rondo, we had this experience. This is the 6th startup that I've done, and I've taken other technologies to large scale in other markets. But we said, is there a way that we could solve this problem with technology that we knew you could make a lot of it right away? Well, one answer is innovate as little as possible, as much as necessary, but as little as possible, and build on existing supply chains and hit that cost target. And the thing that we're doing at Rondo, a lot of people are beginning to do. There's been a recognition that this thing that we call heat batteries is a thing. Systemic wrote a study that says this is going to be 20% of global CO2. Tesla wrote a study that says there's going to be twice as much heat battery capacity installed in the world as grid batteries of all kinds. That's nice, but you got to prove it, and you've got to build with technology that works. And after a lot of searching, we recognized, and I think you know, that we found a technology that the steel industry started deploying in the 1850s, and a heating technology that the world started deploying in the 1930s, and we found a way to combine them. And that was the foundation of this company. There was one engineering physics insight that we could use those things in a new way, solve this big problem. We're now 5 years into that, and I have gone on way too long with my answer to your question.
Not at all. It's brilliant. Thank you. We're going to unpack a lot of this, and then we're going to talk about the technology itself and what your solution is. One of the things I want to say, and as I'm listening to you, and as I was thinking about getting an opportunity to speak with you, was that the lessons that you've learned having started 6 companies, having worked on thermal energy, solar thermal, trying to think about this problem for many years before starting Rondo, with a real keen understanding of what it takes to build technology and build projects that are financeable for infrastructure that are going to repower industry. This is not I'm going to be ageist here, but a 25-year-old wonderkind can't build this company. A 30-year-old can't build this company. I'm not even sure if a 40-year-old can build this company, because the lessons that you know and your team knows, born of success and failure and a lot of trying in different parts of the world to put all these pieces of the puzzle together that you've just spoken about. When you say it, it's like, oh yeah, okay, John, that all sounds logical. But I know that those are hard-won lessons that inform the approach to Rondo. We're in a new era with renewables and cost, and I think we have an approach where we're now going to create the unlock to make heat batteries to solve this big climate challenge and decarbonize industry without deindustrializing, as you've said, to use your words.
Yeah, people gain experience in industries in different ways at different times. And there are members of our team who are early in their careers who have been building and running giant oil and gas and renewable energy facilities in other businesses. It takes folks with interest and insight in the stuff that's new and experience. Actually, one of the real challenges has been there's an insight and you can do it on your computer or in a lab. And then you're testing many things. Most of them fall away. You have some things you're now taking to a larger scale and then a larger scale. It takes a larger and larger team and a more and more diverse team. The 2 solar companies that I helped build previously both ran into the wall of infrastructure finance not being ready to accept technology that was not yet proven enough. Now, it was proven at the tens of millions of dollars scale, but not at the billions of dollars scale. Technologies aren't relevant to solving climate unless they're built at billion-dollar scale. Dave Danielson of Breakthrough says there are no gigatons without gigabucks. That's true. And climate infrastructure technologies as a whole create one of the greatest business opportunities in generations. There are opportunities as these technologies mature to swap fuel for steel, to swap operating capital for infrastructure capital, to create these massive assets. And of course, the solar industry, the wind industry are perfect examples of that. And this is a next step in evolution beyond that. Huge investments in electrochemical batteries serving the grid are driving huge further investments in wind and solar for the grid. We are a platform technology to do that same thing for this next tranche, which is industrial heat. But that doesn't happen unless you're ready for infrastructure finance. Now, people have learned those lessons, in some cases, down a completely different track. They were a developer in a technology agnostic company, and early in their career, they saw boom and bust in solar. There are many paths here that can teach some of those lessons. But as the company evolves, you do need a team with a different mix of skills. 2 of our great triumphs at Rondo, I would argue, we brought in as an advisor a guy who had a career in the cement industry, had thought deeply about all the different pathways to decarbonize cement. And over time, he was our slowest recruit. He stood up as a senior advisor and then president and then CEO. And at our founding Series A investment, we had international cement manufacturers among our investors that created knowledge and sort of North Star guidance in one direction. We also had electric power utilities among our investors early on, helping us understand in the world where we electrify everything, the electric utilities are at the heart of that, enabling it, profiting from it, or standing in the way, depending upon how we work with them. Do we work with them properly or not? But more recently, we've done this project in Europe with the European Investment Bank, and Breakthrough Energy's project infrastructure finance team, a team who came out of large PE shops that do large infrastructure finance. Working with them sort of kind of nearly killed us. It took a lot longer than we thought, but we as an organization have matured in that we are now building infrastructure financed facilities and are ready to do that now at larger scale. It's more than just building the software, building the product, building market awareness that this class of product exists, but building the organizational maturity to be able to show everyone that we are a company that can deliver on time, on budget, safely, globally, and meet the performance and execution standards and reliability standards that infrastructure capital needs. That's a stage of our journey that we're on right now, setting the stage with projects in 5 countries that, as they come online, will enable kind of hypergrowth in those locations.
I love that, and I appreciate you walking me through it, walking our listeners through it. Because when we're talking with companies, and now we're going to get much more basic and elemental here, we're going to talk about what is the heat battery, the fact that we're now in the age of clay or brick or what have you. But we're always looking for that aspect, like what's the superpower here? Who's the team? What are the lessons they've learned? How are they building this business and setting the stage for this business to grow? Recognizing that in order to succeed, it needs to be the right vehicle for billions and billions of dollars to flow into it. It's going to have to appeal to your customer. It's going to have to appeal to the supply chain. It's going to have to appeal to the finance community. So if you would, tell us about the Rondo heat battery.
Let's start with the use case. A huge portion of the heat energy that's used by industry in the world is delivered as steam. Chemical parks, refineries, food producers, the paper, the huge portion of commodities, except steel and cement, something like 80% of all the industrial heat in the world is delivered as steam, and a huge portion of that steam is delivered from what are called cogeneration plants. You make high temperature heat, you drive a turbine that makes some electricity, and the waste heat from that turbine, instead of being thrown away, is delivered as steam to an industrial producer. What they call combined heat and power or cogeneration. That's the most efficient way of using fuel to make electricity and steam. And around the world, there are millions of boilers at one size, and something like 80% of the world's steam is at larger facilities. By energy, Matt, total energy. By total boiler count, there are many more tiny ones, but the things that we're focused on are, let's go get 80% of 60% of total world industrial heat. And we'd had experience building solar industrial heat, knowing everything about safety standards, pressures, temperatures, all of those things. So that's the challenge to solve. Now, how do you do that as simply as possible? Again, something like 2/3 of the existing steam at these industrial facilities, there's a gas turbine, like a jet engine, that the exhaust heat from the jet engine is running through a boiler. It's also called a heat recovery steam generator. Those things, that together, you get electricity and steam at super high efficiency. The exhaust from a gas turbine is at about 600 degrees C. Maybe a little hotter. So you're making steam from superheated flowing exhaust. What if we built an energy storage system that used exactly that same boiler, but instead of feeding it with 600 degree jet engine exhaust, we just gave it 600 degrees C clean air, and we gave it a continuous source of air. Now, all the hard yards, all the reliability, all the maintenance issues with steam systems is the boilers themselves. We could just work with the existing boiler manufacturers and change not a single thing. Okay, what do we store the energy in? Because most of these large industrial facilities, they get turned off like once or maybe twice a year from maintenance for a day or two. Sometimes it's a little longer than that, but the rest of the time they operate 24 hours a day. And what is critical is that they have a continuous energy supply during that period. The biggest challenge when we were making steam from sunshine directly was that variability, which is why we spent a lot of time looking for heat storage technologies that could scale, that could be safe, that could be cheap enough, and failing to find them then. So how do we store energy cheaply? If you have an electric oven at home and you put a stone in it, heat up the stone, put it in your bed, You took electrical energy, you turned it into heat, and you stored it and delivered it where you wanted the heat. Now, unfortunately, part of the night the stone is too hot, it's going to burn your feet. Part of the time it's delivering low temperature heat. We need to figure out that problem. We need to deliver continuous, the same temperature heat. That matter, the steel industry figured out in the 1850s. They figured out a way to store heat that was coming out of the blast furnace. The exhaust from a blast furnace is still on fire, by building a 30-meter tall tower of brick with air passages that gets heated up by the combusting exhaust. And then you take that tower, you blow air the other direction through it, and you get 1,200 degrees C air out that you stick into the furnace, and you reduce the coal that you're burning because you're capturing waste heat. And you have a couple of those towers. One's always heating, one's always cooling. There's about 1 million tons of that brick in service around the world today. And because the way that tower is designed, it's heated from the top down, it's cooled from the bottom up. It actually does deliver the same temperature the whole time it's delivering heat. So we took that. But then the other problem is, how do you heat it with electricity quickly? Because the other thing we want a heat battery to do, yeah, we want 24-hour delivery, but the electricity being free at noon, yeah, but it's free from 10:30 in the morning until 1:30 p.m. or something. The periods of curtailment over generation, whether it's wind or solar, they're brief. So we want to be able to charge as quickly as possible. And because we're building big things, we also want them to be able to connect at the highest voltage possible. Because transformers and circuit breakers and all that stuff, when you're moving a lot of power at low voltage, it's expensive. The Rondo superpower, the insight, arose after a lot of exploration, much of which could not be done without modern supercomputer simulation. That if we'd made a 3D checkerboard of brick and open chambers, we could put heaters inside that checkerboard and deliver electricity to heat inside the structure. There's no place for energy to go. It's lossless. It's zero loss. And we could arrange to use the same heating element material, literally, that is in your toaster and your hair dryer, but connect very long strings so they operate at tens of thousands of volts. They operate at medium and high voltage directly, and come up with something that, from the electricity input to the outlet steam flange, is 98% efficient at capturing energy and delivering it. Higher efficiency than any other kind of energy storage there is, and vastly cheaper because I'm taking this clay brick material the world makes a lot of, and when you heat it to about 1,000 C and then cool it back down, it stores about as much energy per pound as a lithium-ion battery pack, but it'll last 50 or 100 years, and it's very, very cheap. It's single-digit dollars per kilowatt hour. So taken together, just those couple of things that I mentioned gave us a technology platform to really deeply solve that problem. And now we can look piece by piece at all this stuff that the world makes in giant volume and ask, okay, how long does that thing last? How long does that thing last? So that early in our life, as we build units, we know how long they'll last. And if we're thoughtful about it and we make them all the same, they're modular, but they're different. Like we build one box with 500 tons of brick and another box with 6,000 tons of the same brick. If we build our modules right, our early experience will provide the foundation for going directly to large scale. We're not building some different product. We're not having to scale some reaction vessel, so that we can early on establish the track record that's needed to go do the big thing quickly.
Yeah.
And that's the lens that we look through all the time, is how do we go faster? Globally, we need to be going 5 times faster in this transition. And we won't without technologies that are adequately proven, and we won't unless it's profitable.
What you're saying resonates on a couple of different levels with me. Before we started Supercool, I had co-founded a company called Planted with a couple of guys from SpaceX. We are building carbon negative building materials, and we went through a similar process to SpaceX engineers. One of them was running the life support systems on the Dragon Crew spacecraft. Happened to move to North Carolina where I was living. I was running a different company at the time, and I was like, I'm going to shut my thing down. If you'll come work with me, let's go build a carbon negative building materials company. And so our approach was, and this is what resonates, we said, look, we want to find something that grows faster than trees so we can pull carbon from the atmosphere faster. We want to have a production technology that turns it into something useful and durable and doesn't give the carbon back. And if we're going to play in the biggest markets, it's a commodity market. It's got to compete on price, and we need some edge. It's got to be better in some way. And so we have this replacement to OSB or plywood. And when we built the first 4x8 press, we were talking to one of the big engineered wood companies, huge company. We were talking with their team. Someone asked us to go do that, a VC who was looking at us, so we kind of reluctantly did. And the VC was saying, oh, well, maybe they can test with you guys. And they just started laughing, and they're like, we don't have any of this stuff. We go to the University of Maine. It's the only press in America, and that's like small for testing. And I remember looking at Wada, my co-founder, and I was like, oh, we're definitely going to win because none of these guys, they don't build their own stuff. But we built that 4x8 press, and then we threw it away because it had nothing to do with the production line we ultimately built, which was a fully continuous press, just different technology that we now have in place. But our pitch to investors and the way we thought about the business was we're going to win in the field because we're going to be cheaper than trees. We're going to win in the factory because we're not going to burn 30% of our material up a smokestack, right? Like we're going to use everything. And we're going to win from a supply chain standpoint because we can put these factories anywhere, be much closer to a customer.
And that's tough, isn't it? In that
hard.
We're not entering a market that, I don't know, pick electric cars, where you can enter the market way above the conventional price, selling directly to people who have a motivation to drive change. Building materials. There's a long path from the guy buying the piece of building material to somebody who wants to rent an apartment. At every step along the way, it's very difficult to bring any kind of green premium into the things that the world makes the most of. And it is changing those things that we need to do the most. So getting technologies to scale that are, as you said, cheaper in every single area. If you want to be lower impact, if you're not cheaper, it will go very slowly. One of the drivers in our previous solar thermal company was interest in low carbon wallboard. If you wind all the way back to Clean Tech 1.0, there was a company that was saying, look, we're going to make lower carbon wallboard because we're going to eliminate the combustion emissions of making gypsum drywall by using other materials that are not gypsum. They struggled with quality problems and with, if it doesn't have the same performance, the contractor who's building the building is taking the materials risk, but he's way removed from the guy who wants the LEED gold building. I admire you doing that in building materials because I just have a little tiny taste of how hard that is. And it's one of the reasons why we've tried to build something that is exactly drop-in. And that's possible now because of what the wind and solar guys have done.
Yeah.
5-10 years ago, everything we're doing at Rondo could have been done 10 years ago, but it was obviously stupid. Everybody said, obviously, resistive heating is never going to go anywhere. Electricity is too expensive, and the world has turned upside down because of what we've achieved with wind and solar and build-out, so that we were able to do this simple drop-in thing without changing anything else. But there are other cases where, yes, we have to change what the material is and then work up and down with that industry to get it adopted and proven. How is that going? How is Planted going?
Okay, well, I'm going to answer it, and then I'm going to turn it back to you. But it's going great. The financing is going well. Early in our process, we had D.R. Horton, the largest home builder in the country, put some capital into the business. They gave us an early order. They did a lot of testing with us. We put our materials very early on a roof of one of their homes in Durham, North Carolina. Our production facility is not far from there. And they've been with us testing out. And it's been a fascinating experience. I mean, just to build that relationship. And to build that relationship, I have gone hunting on DR's ranch in West Texas, where I was like, of course, let's go. I'm happy to be in a blind and hunt whatever we were hunting.
Javelina? What was it?
Yeah, well, they were there. You were allowed to shoot them, but the one rule when we were at the ranch that they made clear was like, you can't win any business this week, but you can lose business. And I thought if I try and hit one of those things and I hit the feeder instead, so I was like, yeah, I'll just stay here for 3 hours in the dark and then just make it through the week. It was a blast. But what I was going to say is, so D.R. Horton, and we've built some other really nice strategic corporate relationships. They've now known us for a while. This past fall, we got an order for 10 million panels. So that's about 90,000 homes. It's going to take us some time to fulfill. But it's for all the reasons. Thank you. And so for all the reasons of validation, credibility, this is going to be in a home for 25 years. How do you prove that out as a young company?
Yeah.
How do you get over that? Right.
Yeah.
There's clear parallels to Rondo. And when I've looked at who's on your cap table and the industrial or corporate investors who are also behind this thing, not just the amazing VCs, the breakthroughs, the energy impact partners, I mean, the stack's amazing, but those other players who are saying, we want to get in early with Rondo, we want to be part of this, we want to help inform your process, and we also are going to need this. That seems to be how you're thinking through these stages, what your opportunity is to get to that place where this is now proven, de-risked. You have the partners who are helping you get there. Is that fair to say?
Absolutely. And thank you. We started with kind of a dream team of investors. Breakthrough did a deep dive looking at the industrial heat sector, which was really valuable, and did deep technology diligence on the very, very simple thing that we do. They sent a quantum physicist to come look at brick, which was it was just awesome. And Energy Impact Partners, being deeply connected to the electric power industry, it was a huge source of education. But as you say, we've been working closely with majors for whom energy is a critical part of their production process. Rio Tinto has very aggressive climate goals and delivers commodities that the decarbonized world urgently needs. We need 7 times more copper, massively amounts more aluminum. Those things can be produced either the same way they are today, just swapping out the energy supply, or in some cases new ways by changing the mix between chemicals and energy. And in many cases, those guys are looking strategically at what are our options for the future. Electrification is one of those options. How will we do that? We've been engaged with companies who are looking at, am I tearing my process around and trying to recapture waste heat and rebuild factories, or am I changing what's up at the front? Am I changing my primary energy supply, and to what? For us, understanding their needs and working with them on what does the end game look like? It turns out that our little assessment, Rondo alone, could enable one of those companies to achieve 80% of its 2035 climate objectives just by deploying us at 3 of their facilities. It's critical to start looking at that end game and then to prove everything with first steps at real production facilities. You learn all kinds of lessons when you're in a real facility that are different than what you thought before you got there. And creating that early alignment, we created a strategic investor advisory board that works in a deeper way, not just with the sales organization and application engineers, but with the engineering team and with us thinking strategically about where should we be focused, how do we use this technology platform in what vertical things for you, and then what's that sequence? Because there's a sequence from the boiler to the ethylene cracker to the hydrogen electrolyzer to the alumina calciner, for example, or the combined heat and power station. What's the right sequence to make sure that we build the base business, we grow, and we solve the deep problems? It's challenging for a mining company to pull together all these different folks, or for Aramco, which operates lots of different businesses in different places in the world, to bring things together and take a look strategically at this technology versus other decarbonization technologies. And that process, which we're running at the same time as we're building out the right now business, These things feed each other in a hugely valuable way. So yeah, until we began working with H&M, I did not know that fashion was more global emissions than air travel, and that there's a big hammer. If we can just get dye and dry, that's 60% of fashion emissions, replacing coal at factories in Southeast Asia with stored solar energy. All right, let's get to work on that. There are businesses that we are in that 5 years ago, if you'd asked me, where is this going to go? We had one set of thinking about where we thought it might go. Yeah. A variety of geopolitical events, including the war in Ukraine, dramatically changed our focus or made it clear where are the places that we can make the greatest contribution right now, and let's go drive those and build the track record of driving economic value, proving the technology there. Building in rainy Denmark is different than building in California is different than... Yeah. Right now, our delivery team says, I have one project where the ambient temperature is 60 degrees C and another one where it's negative 55. So, and it's got to be one product.
As I'm listening to you and just reflecting back, it can be a double-edged sword to bring on some of these major industrials from our experience. I mentioned this relationship with D.R. Horton. That's been wonderful, mutually beneficial, and I'm not sure the business gets to where it is without having a corporate that just does a lot for what we're trying to accomplish. I'm not sure. But there were others that we entertained where ultimately we felt, you know what, if we bring this company onto our cap table, if they come in at our Series A, I'm concerned this is going to be more of a distraction for our company than it is going to be beneficial. I'm concerned we're going to be their R&D lab. They're going to get a lot out of it. I'm not sure necessarily that that's going to be right for us. And so we looked at things through that prism. The other thing that you said, and I'm curious to understand this more as it relates to where you're focusing your business maybe in the short term. For our business or with Planted with materials, the war in Ukraine, or what that means for Baltic birch coming in from Russia. There's supply chain disruption to our industry. That's really opportunity. Tariffs on Canada, as much as I have my own personal views on whether I think that's a good idea or not, it's great for Planted because, again, that's supply chain disruption. And we have a business that's nimble enough to react. And so you're talking about, okay, you got this war in Ukraine. They've got issues around where is their energy coming from. I assume that creates opportunities for you guys because you then are able to help essentially localize their energy production more around wind and solar because, hey, the more wind and solar you come in, we've got a solution for you to take full advantage of it. Being somewhat opportunistic in how you're looking at where the shorter term, medium term opportunities as we're also thinking about the big picture.
To survive and grow, we need to find the places where we create the greatest contribution and we can deliver to that contribution right now. There are several pieces of that. One of them is what's the availability and cost of hydrocarbon energy, and what's the availability and cost of renewable energy. And we're building a project in northern Germany. That project is located just a couple of miles from an LNG import terminal that was built in like 10 months because of the Russian gas crisis. That LNG import terminal delivers energy that's about 3 times more expensive than it used to be. Germany's chemical industry has shrunk 40% since the war. Industry used to be the single largest user of gas in Europe. It was industry, residential heat, electric power. Industry across Europe has shrunk dramatically because of that price shock that's rippled through, and we're now seeing layoffs in the auto industry because one of the German chemical CEOs not long ago said, look, if we can't make ethylene, we can't make polyethylene, we can't make plastic parts, we can't make car doors, we can't make cars. These primary commodities, supply chains affect economies, and energy is at the heart of a lot of supply chains. We are at a point right now where we are able to get grid connections. We can deliver long-term energy supplies at half the price of natural gas across Germany. Right at now. A major discount right now across. Wow. So part of our journey is working with regulators to speed up getting grid connections. You know, every industry, if it's buying 3 times more energy in the form of gas than electricity, as we electrify it, we need to upgrade its grid connection a bunch. That can take 5 or 7 years. That company may be out of business in 5 or 7 years. Broadly, we're doing a lot of work, which is urgently needed, to connect new renewable generation to grids, to stiffen up long transmission lines. All of that is great, but the interstate highway system isn't very useful if you don't have a driveway. So there are other pieces now, as the world is figuring out with other kinds of energy storage and us, to connect flexible electrical loads into the grid, where electrifying industry is not going to mean having to build more transmission. We're going to move more power through the grid we have. But we need to change access rules. We need to open markets to enable access to real-time prices. We need to get connections. We don't need a new tranche of any kind of subsidies. We just need sort of regulatory, deregulatory changes. That kind of journey that we're on is one of the pacing matters for us. And some of that's been made more urgent by, for example, the Ukraine war in Europe, where, the shift to domestic green electrons. I was in a meeting with President von der Leyen where she said, look, we're in two wars, the land war and an energy war. The bullets in the energy war are domestic green electrons, and they are now an engine that can lower operating costs for industry and stabilize and rebuild industry. That same thing is true here in the United States. Last year, there were 2,000 hours of negative electricity prices in Oklahoma. But the regulatory frame is not the case there, where flexible load can tap into them, harvest them, and lower manufacturing costs for producers in the Panhandle in Oklahoma and up into the Midwest. There are conversations about modernizing electricity regulations, deregulating, to make it possible for American manufacturing to benefit from the deployments of renewables that have already happened. And in a lot of cases, our journey globally is working with markets as markets open, understanding what's open now, and working to understand how do we engage usefully to help drive that further, because Southeast Asia is one example where country by country changes in electricity regulation, the massive investment in that area that's people's China plus one strategy. We're either going to build a lot more regret coal infrastructure, or we're going to build on a clean infrastructure, and just tiny little regulatory changes are the things, because our technology exists now and wind and solar and finance costs are what they are. We're at really interesting moments of opportunity in different places in the world. And as a small team, one of our biggest challenges is focusing on where we can grow right now while we're doing that wayfinding on the longer term things.
You all must be incredibly excited sitting on a technology, and for you, having been in this industry and your team coming back together to do Rondo, seeing the moment of now we're in this new world with renewables. We can tap into intermittent energy. Solar is the cheapest form of energy in the world. And just wanting to take that opportunity and go and recognize that, gosh, there's geopolitical consequences and opportunities if we can figure this out. I mean, it's such a strategic technology that you have, not just in terms of the climate crisis, but I mean, we're talking about geopolitics and what this means for nations. So there's so much there that's so rich. With all that said, I know we have a couple minutes left, and I would be remiss if I didn't ask you about whiskey.
All right. That was all really well said. Systemic wrote this excellent report on this technology. They say the prize is 20% of world CO2. And if it's profitable for everybody at every stage, we are talking about a richer world, not a poorer world. So that stuff is really critical. Now, you mentioned whiskey. What was your question?
I know you're working with Diageo.
Yeah.
I'm probably right on the Bourbon Trail there in Kentucky. And
They make some fine product.
I know our listeners are going to want to, I would like to hear about that. Maybe bring to life a little bit more what this looks like as you engage with someone like a Diageo or with their types of brands in their factories. What is that project? Tell us a little bit about that.
Yeah, it's one of the things we're most proud of. They were sort of emblematic in working with large producers for whom energy is an important cost. In many cases, they also have important climate goals. But everybody is working where energy in many cases is a meaningful part of total cost of production. And if we prove the technology in one facility, we're working with them to understand, okay, what does this mean globally? Where are the places that we will take this once we prove it here? Diageo in particular have a team that have been doing all kinds of things. They've been pioneers in other places in waste heat recovery. They've built systems with electric boilers. They built systems with heat pumps. They are trialing and gaining operating experience in different places in the world with different things. They were doing a competitive thing for one particular distillery, and for a mix of we're going to find a place to test and prove this technology and economic reasons, we're delighted that they chose us. And we are at a distillery. It's in Kentucky, and it is a project that we're excited to be turning on because I host site visits to other projects. I was in Thailand just the other day hosting a site visit at a cement plant, and ultimately, once these things are online, there's a different set of reasons for visiting different facilities. You know, we're making alcohol today in California at a biofuel refinery, but it's fuel alcohol. Yeah.
Brilliant. Well, John, thank you for coming on the show today. I learned so much, and I'm so inspired by what you all are doing. I'm excited to continue to follow and wish you all the best of luck.
Thank you so much. Thank you. One of the things that is most challenging is that almost nobody knows about this new asset class yet. And I'm really grateful to get to talk to you, and I want to hear more about Planted.
I'll meet you in Kentucky.